These are your notes for Unit 7, Day 2 of Calculus. If you would like to see your warm-up, review question, or any homework questions we covered in class today, just look at your finished notes. So today we're going to continue talking about displacement, velocity, and acceleration. We're going to be able to determine a particle's displacement functions if given a velocity function or given acceleration function, determine its velocity function. We'll be able to calculate critical points of a function. We'll be able to determine when a particle is at rest and when it changes directions, and we'll be able to find the total displacement and total distance traveled by a particle. So displacement is your distance from the origin. So it's how far you are from the origin after you start. That is your displacement. So displacement can be negative or positive. So suppose a particle moves with the velocity function v of t equals cosine pi t along a coordinate line. Assuming that the particle's coordinate, the displacement is 4 at time equals 0, find its displacement or position function. So if we're given velocity and we want to get back to displacement, we have to integrate. So the integral of velocity is going to be your displacement function plus some constant c. So to find our displacement function, we're going to integrate cosine pi t dt. This is going to be a u substitution problem. So u is going to be pi t. And so du, the derivative of pi t, is going to be pi dt. And then get rid of the pi, so divide both sides by pi. So 1 over pi du is going to equal dt. So I'm going to replace that pi t with u, and I'm going to replace that dt with 1 over pi du. I'm going to pull the 1 over pi to the outside, and then I get cosine u du. Well, the antiderivative of cosine is sine, so I have 1 over pi sine u. And so it's going to be 1 over pi sine, and then it's going to be replaced with the pi t, and then plus c. So that's going to be my displacement function. That is my general solution, but they gave me an initial condition. They're telling me that if I plug 0 in for the time, I get a displacement of 4. So s at 0 is equal to 4. So my displacement is going to be 4 if I plug in 0. So that's 1 over pi times the sine of pi times 0 plus c. Well, the sine at 0 is 0, so 4 is going to equal c. So now my final displacement equation is going to be 1 over pi times the sine of pi t plus 4. And that is my displacement equation given that information. So again, if you're given velocity and you want to find displacement, you integrate velocity. Then use your initial condition to find the c. All right, so let's say we're given our velocity function is 6 sine 3t, and our displacement is 4 when the time is 0. So let's integrate. So we're going to integrate 6 sine 3t dt. So u is going to be 3t, so du would be 3 dt. Divide by 3, divide by 3, so 1/3 du equals dt. So I'm going to pull out that 6, and I'm going to pull out the 1/3. So I have 6 and 1/3, so 6 over 3 equals sine u du. So that's going to be 2. The antiderivative of sine is negative cosine, and then replace, so negative cosine 3t, then plus c. That's my displacement function, which is negative 2 cosine 3t plus c. Well, I know if I plug in 0, I should get 4. So plug in 0 and I get 4. So 4 equals negative 2 cosine times 3 times 0 plus c. The cosine of 0 is 1, so this is going to be 4 equals negative 2 times 1 plus c. Add the 2, so my constant is going to be c. So my displacement function, s of t, equals negative 2 cosine 3t plus 6. You guys try the one below. So if the velocity function is 6t squared minus 18t plus 12, and your initial condition is the displacement at 0 is 3, see if you guys can find your displacement function. You can check your work against the finished notes from class today. All right, displacement versus distance. So displacement can be negative or positive. The sign indicates direction. Distance is only positive. So how do you find displacement? Well, displacement, you would just add up all these pieces. So you would take A1 plus A2, but A2 is going to be negative, and then you would take plus A3. So displacement would look like a1, then minus a2 because it's negative, then plus a3 because it's positive. Your distance would view a2 as positive. So you would take a1 plus, then you would take the absolute value of a2, then plus a3. So distance, you pretend that this little piece right here, even though it's a negative displacement, you pretend like it's positive for distance. And that's going to be the difference between displacement and distance. So if you want to find displacement, you just integrate velocity. That will give you displacement. If you want to find distance, you need to make sure that your velocity is always positive. So you take the absolute value of the velocity function, and that will give you the distance. So displacement, you just get to integrate velocity. For distance, you have to integrate the absolute value of the velocity function. All right. So suppose a particle moves along a coordinate line so that its velocity is given by t squared minus 2t. Find the displacement between 0 and 3. So for part A, we just get to do it like normal. So we're going to integrate t to the second minus 2t dt, and we are integrating between 0 and 3. So this is going to be t cubed over 3 minus t squared. We don't need a c because I have limits of integration. So this is going to be 27 over 3 minus 9, and then minus 0 minus 0. So this is going to be a displacement of 0. So the particle is going to end where it started. Okay, the distance traveled is going to be, we're going to integrate between 0 and 3, and then we're going to take the absolute value of t squared minus 2t dt. Well, to make sure that we're taking the absolute value, we need to figure out where this particle changed direction. So at some point, the displacement is negative, so it's below the x-axis. We got to figure out where that happens. So we're going to take t squared minus 2t and set that equal to 0 because this is my velocity function. We're going to factor out the t, and then we have t minus 2. So we have t equals 0, and we have t equals 2. Well, we want to go between 0 and 3, so the 0 is okay. So what we're going to do is we're going to integrate from 0 to the other number. So we're going to integrate from 0 to 2, t squared minus 2t dt. And then we're going to integrate from 2 to 3, t squared minus 2t dt. Now, one of those is going to be negative, but if we want to find the distance, then we're just going to switch it and make it a positive. So let's do this. This would be t cubed over 3 minus t squared between 0 and 2. And then this would be t cubed over 3 minus t squared between 2 and 3. So this would be 8/3 minus 4, and then minus 0 minus 0. And then this one would be 27/3 minus 9, then minus 8/3 minus 4. Well, this would be, get a common denominator over 3. So this would be negative 4/3. And then this would be 9 minus 9, which is 0. And then that would be positive 4/3. Okay, well, that displacement is negative 4/3. But if we want to deal with distance, we take the absolute value of that. So that's going to be 4/3. And then the other side was 4/3. So the distance traveled by that object would be 8/3. And we can do this on your calculator. So if we were to integrate this on our calculator, you have an absolute value function. You hit math on your TI and then go over 1. And then the ABS is absolute value. So we're going to hit the integrals function, so integrate. And we want to integrate between 0 and 3. And then we're going to integrate the velocity function just to start off with, which was t squared, so x squared minus 2x, and then dx. And notice that's 0, so that's the displacement. If you wanted to take the distance, you would take the absolute value of this. And so you would just put it in absolute value bars. And notice you get 2.67, or 2.67, which is 8/3. That is 2.67. And so your calculator can take the integral of something in absolute value. So you can do it by hand by finding the zeros of velocity and then integrating by breaking it up, or you can do it with your calculator. speed versus velocity. So remember, speed is the absolute value of velocity. So if you want to know when a particle speed is speeding up or the speed is increasing, remember this is when you need to look at the velocity and the acceleration. So a particle is speeding up when velocity and acceleration have the same sign. So when velocity and acceleration are working in the same direction, the particle will be speeding up or the speed will be increasing. A particle speed is decreasing, so the speed's decreasing or it's slowing down when the acceleration and velocity are working in different directions. So when velocity and acceleration have different signs. So let's say we just want to look at t equals 3. So at t equals 3, what's happening in this function? Is the particle speeding up or slowing down? So we find the velocity function. The velocity function was 3t squared minus 12t. And so our velocity at 3 would be 27 minus 36, which is less than 0. So at time equals 3, the velocity is negative. And then we look at the acceleration function. The acceleration function is 6t minus 12. And the acceleration at 3 would be 18 minus 12, which is positive. So since the velocity is negative and the acceleration is positive, that means that the particle is going to be slowing down at t equals 3 because the velocity and acceleration have different signs. And that's how you tell if a function is going to be, or a particle is speeding up or slowing down. So you guys go ahead and say if this particle is speeding up or slowing down at t equals 1. So you can pause the video and try, and at t equals 1, is that particle speeding up or slowing down? All right. Interpreting data from a graph. Find where the particle is at the end of the trip. Well, this is a velocity function, and so to figure out where the particle is at the end of the trip, we need to find the integral from 0 to 10 v of t dt. Well, that's going to be the area under the curve. So this area right here, that's a triangle. It's base times height divided by 2. So it's 2 times 3 divided by 2. So that area is 3. And then down here, down here we have a trapezoid. And to find the area of a trapezoid, we take base 1 plus base 2 times the height divided by 2. So base 1 goes from 3 to 6, so it'd be 3. Plus base 2 goes from 2 to 7, so that'd be 5. Times the height, which is 3, then divide by 2. And so that would be 8 times 3 divided by 2, so that would be 12. But since it's below, that displacement's negative, so that displacement would be negative 12. And then this guy right here is a triangle. So base times height divided by 2, so that'd be 3 times 3 divided by 2. So that'd be 9 halves, or 4.5, and it's positive because it's above. So the total displacement is going to be 3 plus 4.5, then minus 12. So it'll be 7.5 minus 12, which should be negative 4.5. So the particle is at a displacement of negative 4.5, or it's 4.5 units to the left or under where we started from. Total distance, well, we're going to integrate from 0 to 10 the absolute value of the velocity function, or we pretend that all the parts are positive. So we'll take 3 plus 4.5, then we pretend like that 12 was positive. So it would be 19.5. So the total distance traveled by the particle, it traveled a total distance of 19.5 units, or meters in this case. When is the particle at rest? Well, the particle is at rest when the velocity is equal to 0. This is a picture of the velocity function. So the velocity is 0 at 0, 2, 7, and 10. So time equals 0, 2, 7, and 10. The particle is at rest. When does the particle change directions? Well, when the velocity is 0 and changes signs. So when does the particle equal 0 and change signs? Well, at 2, the velocity changed from positive values to negative values. And at 7, the velocity changed from negative values to positive 7. So the particle changes directions at t equals 2 and t equals 7. When is the particle moving to the left? Well, it's moving to the left when the velocity is negative. So the velocity is negative between 2 and 7. So from 2 to 7, the particle is moving to the left. When is the particle moving to the right? When the velocity is positive. The velocity is positive from 1 to 2, or sorry, from 0 to 2, and from 7 to 10. So that is when the particle is moving to the right. When is the particle furthest to the left. So it is furthest to the left at 7, because that is when the displacement is going to be 3 plus negative 12. So at 7, the displacement is negative 9. So that happens at time t equals 7. And when is the particle furthest to the right? Well, at 2, its displacement is 3. And at 10, this displacement is negative 4.5, because that little piece is positive and that little piece is positive. So when is it farthest to the right? It's farthest to the right at t equals 2 when the displacement is 3. If you want to find a net change in displacement or velocity, etc. So if you want to find a net change in displacement, you integrate velocity over the interval. So from a to b dt. If you want to find a net change in velocity, you would integrate acceleration between a and b dt, right? So a net change in displacement is displacement at b minus displacement at a, or a net change in velocity is the velocity at b minus the velocity at a. So here are free fall formulas that you can use to help you do some problems. So a displacement function can be given as your initial displacement plus your initial velocity times time minus 1/2 times the gravitational constant times t squared, or the velocity equation can be given by velocity is given by the initial velocity minus the gravitational constant times time. So we did this problem in class today, so you guys can look through this problem, see how you do, and then check your work against the notes from class today. And then we are moving on to this unit's free response type problem. So we did 2 examples of these today. So between 0 and 6, a particle is moving along the x-axis. The particle's position, x of t, is not given. The velocity of the particle is given by this function, v of t equals 2 times the sine of e to the t over 4 plus 1. The acceleration is given by 1/2 e to the t over 4 cosine e to the t over 4. And the initial condition is the displacement at 0 is equal to 2. Is the speed of the particle increasing or decreasing at time equals 5.5? Give a reason. Well, for speed to be increasing or decreasing, we look at acceleration and velocity at the given time. So we need the velocity at 5.5, and we need the acceleration at 5.5. So we're just going to use our calculator, and we're going to plug in these values into our equation. So it's going to be, make sure you are in radians. We are. So it's going to be 2 times the sine of e raised to the x over 4, so x is 5.5, and then divided by 4, and then plus 1. And so the velocity at 5.5 is going to be negative 0.4.53. We'll go out 3 decimal places. And then the acceleration at 5.5 is going to be 0.5, and then it's e to the t over 4, so it's going to be raised to the 5.5 divided by 4. And then times the cosine of e to the 5.5 over 4. And no plus 1. So this acceleration at 5.5 is going to be negative 1.3585. So we'll do 359. Notice the acceleration and velocity are both negative. So at t equals 5.5, the speed of the particle is increasing because the velocity and acceleration have the same sign. The speed is increasing because v at 5.5 is greater than 0, and the acceleration at 5.5 is greater than 0. Or you can write that the acceleration and velocity have the same sign. Find the average velocity of the particle between 0 and 6. So average velocity would be change in distance over change in time. So we need to find the change in displacement. So average velocity is going to equal change in displacement over change in time. To find our change in displacement, we need to integrate the velocity function. So we're going to integrate the velocity function between 0 and 6. So we're going to integrate 2 sine e to the t over 4 plus 1, and then we're going to divide by the change in time. So again, we're going to use our calculator to find that integral. So we are going to integrate between 0 and 6. And then we are integrating 2 sine e to the x over 4. And then plus 1. And then dx. And then we are going to divide that by 6 minus 0, so divide by 6. And so my average velocity is going to be 1.949. And do we have units? Nope. So that's going to be my average velocity, change in displacement over change in time. For part C, it wants the total distance. So remember the difference between distance and displacement. For distance, we're going to integrate the absolute value of velocity. So we're going to integrate the absolute value of 2 sine e to the t over 4 plus 1. And then we want it from 0 to 6. So that's going to be my total distance traveled. So again, we'll go back to here. And then 0 to 6. And then this time, let's erase that. Erase that. And then this time we're going to take the absolute value of that. So we'll put this guy in absolute value and we'll end it there. And so the total distance traveled by this particle would be 12.573. Between 0 and 6, the particle changes directions exactly once. Find the position at that time. So for a particle to change directions, we need the velocity to equal 0 and change signs. So now we are going to graph our velocity function, and we just care between 0 and 6. So we're going to graph it. Y equals 2 sine, and then e to the x divided by 4, and then plus 1. And we just care about this between 0 and 6. So between 0 and 6, it changes directions exactly once. So that's when the velocity equals 0 and changes signs. So that's going to happen at t equals 3.046 from the graph. So that's the time at which the velocity is equal to 0. So that's and changes sign. So that's when the particle changes directions. It changes directions at 3.046. We want to know what the displacement of the particle is at that time. Well, to find its displacement, we integrate between 0 and 3.046, and then we're going to integrate the velocity function. So 2 sine e to the t over 4 plus 1 dt. And that's going to be how far the particle traveled between 0 seconds and 3.046 seconds. But the particle has an initial displacement. So at the start of the problem, the particle is already 2 units to the right. So it's going to be 2 plus however far the particle travels, or its displacement between 0 and 3.046 seconds. So again, we're going to use our calculator now. So it's going to be 2, so that's the initial condition. It was already 2 units to the right, and then we're going to integrate. We're going to integrate between 0 and 3.046, and then the function, so 2 sine, and then e to the x divided by 4, and then plus 1, and then dx. Oops. Oh, man. So 2 plus, and then we're going to integrate. And we're going to go between 0 and 3.046, and then where it's going to be 2 sine, and then it'll be e to the x divided by 4, x divided by 4. And then dx. And we get that the position of the particle at that time would be 7.754. So again, we wanted to know the position of the particle when the particle changes directions. Well, the particle changes directions when the velocity is equal to 0 and changes sign. So that on the graph happened at 3.046. So this is the time, 3.046, when the particle changed directions. So we're going to integrate from 0 to 3.46. and that'll be the distance, the displacement, sorry, of the particle between that time. The particle started at the start, the initial condition was at the start of the problem, the position of the particle is 2. So at the very start, you are already 2 units in the positive direction. So we're going to take 2 plus the displacement that accumulates between 0 and 3.046, which ends up being 7.745. All right, let's look at another one. A particle moves along the x-axis with this velocity function, 10 sine of 0.4 t squared divided by the trinomial t squared minus t plus 3 between 0 and 3.5. At time equals 0, the position of the particle is negative 5. Find the acceleration of the particle at t equals 3. So in order to do that, you would have to take the derivative, or on your calculator, remember to do a derivative on your calculator, you can hit math and then 8, and that would take a derivative of that function. I'm actually not sure if Desmos can take derivatives by hand. Let's look at our functions, miscellaneous. Oh, it can. So Desmos is going to allow us to take the derivative at time equals 3. So we're going to take the derivative of, and then it's going to be 10, and then it's going to be sine, and then it'll be 0.4, and then it's t squared, so x squared, and then end that, and then divided by x squared minus x plus 3, and that's the derivative function. And we want to find that when x is equal to 3. So let's type in x equals 3. And so where they intersect is at negative 2.118. So the acceleration at that particle, if you're using your calculator or using your Desmos, the acceleration at time equals 3 seconds would be negative 2.118. Find the position of the particle at time equals 3. Well, to find position, we're going to have to integrate the velocity function. So we're going to integrate between 0 and 3, and then we'll integrate our velocity function. But it already had an initial displacement. At the very start of the problem, the particle was already at negative 5. So it was 5 units in the negative direction. So we're going to take negative 5 plus the accumulation of displacement between 0 and 3. So we'll integrate velocity. So let's do that. So we're going to take negative 5 plus, and then we'll integrate our velocity function. So integrate, and then it is between 0 and 3. And then it'll be 10 sine, and then 0.4 x squared, and then divided by x squared minus x plus 3, and then parentheses, and then dx. And so the position of the particle at time equals 3 is going to be negative 1.760. Now it wants me to evaluate between 0 and 3.5. So if I evaluate between 0 and 3.5, the integral velocity. So now I'm just going to erase this. And then instead of 3, I'm going to do 3.5. I get that displacement is going to be 2.844 if I round. And then if I do the integral of the absolute value of velocity between 0 and 3.5, so now I'm just going to throw in some absolute value bars. Oops. Oops. X squared minus x plus 3. Whoops. Okay, let's just start over. So we are going to integrate between 0 and 3.5. And then this time we're going to do the absolute value of 10, and then sine, and then 0.4 x squared, and then divided by x squared minus x plus 3, and the absolute value, and then dx. And we get the distance traveled between that time would be 3.737. And then it said interpret the meaning. So this is the net displacement. between t equals 0 and t equals 3.5. And this is the total distance between t equals 0 and t equals 3.5. A second particle, so this is part D, a second particle moves along the x-axis with the position given by t squared minus t between 0 and 3.5. At what times are the particles moving with the same velocity? So we want to know when their two velocities are the same. So for part D, the velocity of the original particle was v of t, which was 10 sine 0.4 t squared divided by t squared minus t plus 3. And we want to know when that's going to equal the velocity of this second function. Well, the velocity of the second function is going to be 2t minus 1. And so we want to know when those two functions are equal. Well, to figure out when those two functions are equal, we just need to know when their graphs intersect. So we're going to graph both of those functions. So y equals 10 and then sine 0.4 x squared, and then divided by x squared minus x plus 3. And then the other one was y equals 2x minus 1. And where do they intersect between 0 and 3? Well, they intersect when time is equal to 1.571. And so that is when their two velocities would be the same on that interval. All right. Your homework is your worksheet over these ideas. Let me